Welcome to the Think Factory podcast. We got one question for you. What keeps you up at night?
Welcome back to the Think Factory podcast, powered by OGC Solutions. I'm your host, Chris Santamassimo, and I'm here today with my friend Bill O'Donnell from FlexLink. Welcome to the podcast.
Why, thanks, Chris. Neat to be here.
And you told me that your kids and your wife think you're cool now that you're a podcast star.
Yes, indeed. I have two teenage kids, one heading off to college soon, and I told them I'd be on a podcast, and they looked at me funny and wondered if I had used the correct word, but no, I assured them it's a podcast and it will be available on the internet. So,
well, hey, if this works out well, maybe we'll just do a series and you'll really impress them.
That would be magnificent.
Pretty cool, right?
That'd be great. Yep.
So Bill O'Donnell is a sales engineer with FlexLink. The company's called Coasia. But I'd love to hear a little bit about FlexLink and some of the things you're doing in the packaging industry.
Sure, no problem. Well, FlexLink has been in business for a long time, over 30 years. Began in Sweden as a division within SKF, the bearing company, the folks that make ball bearings, essentially, for cars, trucks, planes, boats, all those things. And internally in Sweden, they needed a way to transport pieces of bearings from machine to machine to machine, grinding, polishing, cleaning, measuring, etc. And it was all done by hand. A person would take these pieces from machine to machine, and a few enterprising, very intelligent engineers there invented FlexLink, invented our conveyor system in order to solve that problem. And they used it in-house for years, and then realized there was most likely commercial applications for this, that the larger world could benefit from this. And then so they commercialized it in Sweden. And then after that, shortly thereafter, it went global. And they set up different offices in different countries. One of them was the U.S. back in the early 1980s. And since then, we've been in the U.S. and doing really well here. And what it has basically led us to is exposure to a lot of different industries. And we could talk more about that. I can get into some of the specifics. But basically, that invention in Sweden was the first of its kind. It was revolutionary in the conveying world, in the material handling world, in manufacturing, in the way we can move materials around from machine to machine, get them there in the right orientation, the right condition, and at the right time, so that the machinery, the equipment used in the manufacture of these things can do its job the best it can.
So you basically fire up the system and let it run itself thanks to the way you're able to connect the pieces.
Correct. Right. You're exactly right. We connect the pieces. Yep. And the connection, if I might say, is it's kind of an invisible part. When it works well, it's almost invisible. It connects the pieces, and the pieces are what people most often notice. But our equipment becomes very noticeable when it doesn't work well. So we're very careful to make sure that we're one of, if not the most reliable part of a production line.
I was about to say, you got to save yourself there. You can't be talking about your equipment not working. Fantastic. So when you talk about the automation of a manufacturing process, that frankly is on the tip of virtually every manufacturing company's tongue. You know, how can we minimize reliance on labor and elevate our employees to do better tasks? Or how can we minimize injuries by trucking around pieces around the factory? But more importantly, how can we be more efficient and more effective? And that's what FlexLink essentially does, I think.
You're exactly right. That's what we strive to do, is get the most products out the back door with the optimal amount of resources, be that equipment or people or labor, things like that. Yep. So we help manufacturers optimize their processes and really make best use of, well, one, their floor space. Most factories right now are pressed for space. Square footage is expensive. We help them do that in a few ways by being a compact system, but also we can take things vertically. We can do things, say, overhead and save space that way. But generally, yes, reduce direct labor content of equipment, reduce ergonomic risks, and increase the amount of time that those machines we talked about earlier can be running. We make sure that they run when they are available to run.
So give me some examples in the packing industry in particular of ways that you're able to make a company more efficient in terms of what it does.
Sure. That's a good question. There are a lot of examples, and let me pick one. I'll pick I'll pick one that is a medical device, let's say, and it is manufactured. It's a plastic item, and it's manufactured, and then it's assembled. There are things that get put onto it, and I apologize if I sound vague. We're under non-disclosure with a lot of our customers. They're releasing new products to the market. They're doing a lot of development, and as such, I need to be pretty vague about it. But the process can be explained pretty clearly. So they manufacture and assemble this product, and then it needs to be packaged, put in a container of some sort to get to the end-use point. And what we help this company do is connect the machines that make the product, first of all, with our conveyor systems. And this included things like changing the orientation of the product, designing the conveyor system so that the product would run more smoothly. It was an oddly shaped product. And as such, it was difficult to convey from machine to machine. So we came up with ways of doing that increased the efficiency of getting the products from machine to machine. Very simply put, they didn't fall over on their way from one machine to another, which was kind of a problem in the past. So we did that. And we also helped them with something called accumulation. And that is when two parts of a process are not running at the exact same speed, one's running faster, one's running slower, sometimes you can get a buildup of product. And being able to hold on to that product for a little while until a machine catches up is pretty important because it means both machines keep running. One doesn't stop waiting for the other because we have that accumulation. So we incorporated that. And that was on the manufacturing side of the product. So that was one whole room that had all the machines for manufacturing that we connected. And then we went through the wall into the packaging area. And in this area, we provided all of the equipment that went into that room. And that included picking up the products, putting them in a box that we made, a cardboard box that we had made and put a plastic bag into, placed the products in the bag, made sure there were the right number of products in the bag using a vision system. That was done robotically, that placement of the products in the bag. Then that case, the plastic bag was folded over the top. And then we did another automation cell, again using a robot, that placed a divider inside the case between the bag and the side of the case, which was a little tricky. That was tricky to do because it was formerly done by hand by a person. And the volumes had got such that that was not practical anymore. They needed more production in a shorter amount of time. So we invented a robot cell to basically do that, which was really neat. And then finally, we did some labeling and some inspection just to make sure that it was the right product and it had the right barcodes, again, a medical device. And then finally, we palletized it, and that is picked the cases with a robot and then stacked them on a wooden pallet that would then get shipped by truck to the end customer. The neat part about that is these products are light and they're a little bit large. So what happens is when you're making a truckload of these, you want to fill as much of the volume of the trailer as you can. We don't run out of weight capacity. The trailers are quite light, so we want to make sure that it's as full as it can be. So we want to build the pallet as tall as we possibly can that will still fit in a truck. So that was a challenge for us as well.
Without falling over, no less.
Indeed, you're exactly right. And there are other processes post-palletizing with wrapping and other stabilizing things that can be done for that. But you're exactly right. To make it a tall load and stable, able to be shipped and handled and get to the end customer in good shape.
That's an incredible number of steps and factors. How many steps were in that process?
Oh, gosh. Okay. If I'm counting from when the product was initially made and then to assembly, I'd say at least 12.
Wow.
And if we wanted to break out the assembly process where the parts are actually brought together and assembled, that's probably another dozen right there by the time you get done inspecting it and checking it. Because, again, a medical device, you can't send a bad product out. Can't happen.
Assuming that you can get enough people to move quickly enough, which was one of your challenges, but how many bodies did you think you took out of the process?
Oh, boy. Sorry for the dead air pause here. Just counting them up. I would say probably at least a dozen, probably more, because this is an around-the-clock operation. Also, they need to manufacture these products around the clock. And with our customers, when we talk about more than one shift a day, more than 5 days a week, you need to look at automation.
Right.
You really need to. Getting 3 shifts of people to come in and do work is getting increasingly difficult and expensive.
For sure. Yeah, so the money savings starts as soon as you turn the machines on.
It does.
Yeah.
It does. And that leads into a lot of pressure to develop and deliver the systems as quickly as we can, because to your exact point, as soon as we hit the on button and commission it, it's starting to pay itself back.
So what are some of the exciting things that you're seeing, develop and grow, whether it's technology or processes or adoption? What are some of the things you see that are particularly exciting and what is already kind of an exciting engineering world?
Sure. There are a lot. The packaging world is ever changing, and it's driven by a lot of different things. A lot of cost and a lot of marketing actually is what drives a lot of development in the packaging world, at least for consumer products. And I characterize that as what you would find in the food store, in the grocery store. But I would say what is making a fairly exciting set of challenges in the market is the use of robotics and how much robots can do. If you've been to a trade show recently, as we were at Pack Expo, you can't hardly walk down any aisle and not hear the word collaborative robot. I'm sure you've heard that term as well. And it's a term that's been very popular and has been used in a lot of different ways. And basically what it is, at a very high level, is a robot that can work in a manufacturing process without heavy guarding and physical barriers around it under certain circumstances. So that's obviously very attractive to people from a cost standpoint, from a safety standpoint, from a floor space standpoint. So we're seeing a lot of deployment of collaborative robots. And we've been in the collaborative robot space, I would say, probably 12 plus years now. We were one of the early pioneers of collaborative robot palletizing. And we can dig into that in more detail if you'd like. And as such, we've got vast experience in deploying these robots from when they were in their infancy. So that's given us a lot of depth of knowledge and a lot of experience to today, where we're getting asked to deploy collaborative robots in more and more complex applications, more and more areas where it really would take a person to do it. Some operations like picking and placing, for example, those are quite simple, and those can be easily done with a robot. But some of the more complex things, like picking products out of a random bin, say a bin with random products tumbled inside, picking those out one by one, that's tough to do.
Right.
Stacking boxes that are random sizes. Imagine taking a tissue box and then a diaper box and then, say a shampoo bottle or some other product and stacking them all on a shipping pallet.
It's easy when they're uniform, but not so much when they're not.
Exactly. So we're seeing a lot of vision, even some artificial intelligence. I know that's a buzzword right now, the use of AI, but I think that's where the real exciting stuff is going to be, is closing that gap between what a robot can do and what a human has to do in a manufacturing process.
Yeah, robots have been great for some time at routine things, repetitive things, but when there's some kind of a thinking involved, so to speak, that's where it gets a little more challenging. But to your point about the odd-sized boxes, right?
It does. Yeah, exactly. And it's sometimes, as people, we take for granted what our eyes and fingertips can do. But the amount of data that we take in and process as a human with just our eyes and our fingertips, sight and touch, is very complicated, extremely complicated, and something that robots really struggle to do. So as we see more sensor technology and more computing power come into it, we can kind of close that gap. And we've all seen the Boston Dynamics walking robots. They're fantastic, and the technology that they're deploying is wonderful. I'm excited to see if that's going to make it into the manufacturing space as well, to that level.
Yeah, that's a crazy concept to me, the idea of walking. I mean, a robot on wheels makes a lot more sense in the environment to me, but I can't imagine that somebody won't figure out a use for it, right?
I would think so. I would think there is a use for it. The concept of a moving robot has been under pretty aggressive development, I'd say. I've seen that where we place a robot on a moving vehicle, a wheeled vehicle, exactly how you describe, and using it to do more complex tasks and moving it from place to place. So there's some exciting things coming up there, especially when we talk about, again, integrating that sensors and that collaborative robot technology so that it can do it safely.
Yeah, I wonder if a pick and pack operation might be something for like that walking robot where it can pick up those odd sized things and put them in, assemble an order and send it out the door by itself,
Yes, indeed.
Yeah.
Yep. That I think is where a lot of folks would want to go. I couldn't say or guess when it would get there, but I know folks are talking about that for sure.
No, it's exciting for sure.
It is, yeah.
What are some of the other success stories that you've seen? I'm sure every time you put in a new installation, it's a success story, but what are some of the ones that stand out for you?
Sure. That's a great question. And sometimes it's tough to pick one, only because we see so many different applications. We could be in personal products or food or beverage or cosmetics, things like that. Let me see here. Let me pick another.
I know I'm putting on the spot a little bit.
Yeah, and that's no problem. This is a typical question that we get.
Yeah.
Tell us about success stories. Of course, we have no failure stories. Those just don't happen, of course. So let me see.
Well, and all kidding aside, I mean that your job, if there is a snafu, is to figure out how to fix it before the line starts. So any failures, quote unquote, sort of get resolved and ironed out in the process.
Oh, indeed, yeah. And that gets into our project management and kind of into the weeds of how we handle projects and how we manage them. And absolutely, shortly or briefly put, we factory test everything we send out so that our customers see it working in our plant before it ends up in their plant. For those reasons, so that we don't send something out that's difficult to deploy in the field.
Yeah, no doubt.
Yeah.
Yeah, I can imagine the packaging space must be ripe for those success stories.
It is. Yeah. Yep. Yeah, there's a lot of them. Let's see. I'm trying to think of one that has some robotics to it that was interesting. We do see a lot of them. The pharmaceutical industry has gotten into the collaborative robots a little bit more. We've done some projects with them in the end of line palletizing, where we're dealing with different size cases and we're dealing with more stringent data handling. I guess that would be an interesting part of a project that we've done with a pharmaceutical company where they need to track a pharmaceutical from when it's manufactured all the way out to when it reaches its end customer with serial numbers and barcodes and things like that. And we've had to add more data handling capability to our robotic system. So no longer is it just an island of automation. It's taking data from upstream and it's saying to another system, hey, I picked up part number XYZ and I put it in this location. And then I took it from this location, I placed it on this pallet and things like that to give them compliance with the regulations that are in the pharmaceutical industry. So that's a little bit more of an exotic aspect of it, is the data handling, what goes on behind the scenes of the cell operating. We can obviously see it picking things up and moving things around, but what's the data? What are the ones and zeros that are happening around that to integrate it into the larger process?
Well, it's a bilateral flow of data as well.
It can be.
Right. It's coming from the manufacturer out to the ultimate purchaser, and then when it's received, it's coming back, and that chain of custody is sort of put together in the computer.
Exactly right. Yeah. Yep. And pretty specifically in the pharmaceutical business to prevent diversion and counterfeiting and things like that, and also to make sure that people are getting what they're expecting to get from medicines, of course. So that's been a challenging yet exciting aspect of deploying automation as well.
Are you seeing an increase in the need for computing power because of all these different applications?
Good question. I'd say generally...
I'm full of good questions. I don't know about answers. You're the answer guy. I'm the question guy.
Okay. Yep. I'll play my role here. I'll give the answers. Sure. I would say computing power, not so much as we think of a computer that's on our desktop, more so in industrial controls, the logic controllers, the robot controllers, they are all using the latest processing power in order to process things more quickly, take more sensor input, respond quicker to inputs, things like that, because that's what gives you that better performance, is being able to take in more data, process it more quickly, and then modify what you're doing.
But everything is sort of linked together in an ERP system too, where data is flowing in multiple directions at any given time. So that's got to be a challenge as well.
It can be. Yes, exactly. And many times when we're doing an automation system, we will have provisions to plug into or to network with a plant-wide automation system. So an entire ice cream manufacturing plant may have a supervisory system that is watching every single process in the plant and making sure that it's operating properly, and we have to be a part of that.
Well, you mentioned visual inspection systems and cameras. That I think is really exciting as well. The ability at high speed for the system to monitor itself and find exceptions and to kick out the rejects, etc. So it speeds up the plant unbelievably. It's fun to watch.
It does. Yeah, and it is. And watching speeds go up, and that's a good point. Watching the speeds at which things are made now is really fantastic. You cannot, with your eye, you cannot see really what's going on. Some products, some things, say we have a customer who makes, maybe packaging products, tin cans or something like that, where they could make them at up to 1,000 a minute. 1,000 products a minute, so 15, almost 20 products every second are going by, and those products are being made, they're being inspected, they're being rejected if they're not to spec, and then being packaged at those speeds. So that is another big push for folks to increase speeds within the same footprint, and again, get further output, and they've increased dramatically. As an example, early on, we've done a lot of work with the personal care industry, and one is underarm deodorant, let's say, just speed stick, if you will. And state-of-the-art production line for an underarm deodorant back in, let's say, the early 2000s would be 100 to 180 parts a minute. Still pretty fast. 3 every second. That's pretty fast. Current state-of-the-art is closer to 800 to 900 a minute out of a single production line, and they are flying. And every single product that gets packed out at the end is perfect.
Because of those inspection systems and the speed of the computing and the robots, all those things together, that's what's fascinating is when it all works together, to your point, and that's what FlexLink does to bring it back home.
It does. Yes. Yep. We connect all those high-speed machines and make sure that they get what they need, when they need it, and in the way they need it, so that they can keep running and making product faster than we can see it.
Do you sometimes, maybe to close out, some of these exciting things that we're talking about?
Yeah.
I'm sure that designing a new manufacturing line from the ground up, it's that's where you play for sure. But does FlexLink also play in trying to improve an existing facility to make it faster and or to upgrade the plant?
Yes. Yep. Yes, we certainly do. There are a lot of production lines out there in the world that run just fine. And maybe they need a little tune-up here and there, or a piece of equipment can be upgraded or replaced. And yes, we'll work with a customer. And one of the nice things about FlexLink is a lot of our stuff is reusable. So if they had a FlexLink line that they put in 10 years ago, and they want to reorganize it, rework it, rearrange it to do something new, we can use a lot of what we did 10 years ago, replace some wear items and things like that, but we don't have to start over new. We can save them money that way, get their line up to current standards, and most likely do it more quickly as well.
Fantastic. Well, FlexLink is really empowering a lot of these companies, I think, to be better and more efficient, save money. So congratulations on that.
Thank you.
Good stuff.
Thank you. It's fun.
So tell folks where they can learn a little bit more about FlexLink or reach you directly.
Sure, no problem. As with everything, it's on our website, www.flexlink, FlexLink.com. Everything is on there. We have a lot of videos and pictures and things like that. It's hard to say everything we do. It might often be easier to say the things we don't do than the things we do, just because of our longevity in the industry and what we've been exposed to. So I invite you to look at the website, and if you have any questions, just pick up the phone. All the phone numbers are there. All the contacts are there. All the emails there. Contact us. Somebody will get back to you immediately. We're happy to help. We're excited to help, and we look forward to it.
That's fantastic. So just to sum it up, this is Bill O'Donnell, the sales engineer for FlexLink Systems with their U.S. headquarters in Allentown, Pennsylvania. So thanks a lot for joining us today.
Thanks, Chris. It was a pleasure being here.
Same. So this is Chris Santomassimo from OGC Solutions. You can reach us at ogcsolutions.com, and we'll see you next time on the Think Factory podcast.